My name is Phil Connaughton. I'm a principal software engineer at Runkeeper. I've been there about 4 years. In my time at Runkeeper, I've worked on our iPhone app, our Android app, as well as helping to create the infrastructure that supports them. Most recently, I built a watchOS 2 app for Runkeeper. So if you guys have any questions about watchOS 2, I'd love to talk to you guys about that after the talk. So let's get started. So today's presentation, I'm just going to start out with a brief intro to what Runkeeper is, just to give you as a background as to why we're focused on location data and the ways in which we use it. So I'll take you through a brief history of location tracking and some of the obstacles at Runkeeper that we've had to overcome with location services along the way. We'll start way back at iOS 2, and I'll take you through iOS 9 and what we can do with location services on watchOS 2. I will outline a few algorithms that Runkeeper uses to exclude inaccurate GPS points. And next, I'll take you through an example of how collecting GPS points can go terribly wrong, and how we've wrecked a few runs for some folks. And then lastly, I'm going to talk just a little bit about what you can do to conserve battery life when you're using location services. Spinning up the radio does take up a lot of power, and so just some things that we do to try and limit that. All right, so first Runkeeper. So Runkeeper got started in 2008 as one of the first apps in the iOS store. We're an inclusive fitness brand that isn't tailored towards elite training and not really trying to help people win their local 5K. We're more focused on reaching the broader crowd and trying to just help people stay fit. So our motto is everyone, every run. Okay, so we use location data in two distinct ways. We use it during the activity and after the activity. So during the trip, we collect GPS points on the fly, analyze them, and determine if they're accurate enough for us to use with the trip. Based on these points, we provide real-time feedback to the users. So we do that in forms of audio cues as well as visual displays. So we'll show them what their current distance is, what their pace is, how many calories they've burned, that kind of information. Additionally, we use broader location data for showing the general area that a user ran in, as well as advertisements, so just regional advertising, and then music as well. So we have an integration with Spotify, and depending on where you are, we will give you region-specific playlists. All right, so let's go back in time to iOS 2. I know that was a lengthy introduction to myself and how we attack GPS, but I think it's helpful to see what we're using it for. So back in iOS 2, you couldn't actually use location services in the background. So as soon as your app was backgrounded, we stopped receiving GPS points. So that posed a huge problem for us because we would have to message to users, hey, you need to keep the phone screen on if you want to be able to track your run. Otherwise, you go out for a run and you make it a block, the phone screen turns itself off, and we don't get a GPS point until your next kilometer. And which is fine if you run in a straight line because we can just draw a line between those 2 points. But if you turn a corner or something, it totally throws off your stats. So users weren't too happy with that, and we weren't too impressed with ourselves. And keeping the screen in the foreground and the screen on crushes your battery life. So if you think GPS is bad for killing your battery life, just try leaving the phone screen on for the hour that it takes you to run. So one of our users actually came up with a solution for us. So like I said, we have audio cues, and the audio cues, he set them to fire every minute. And so they would fire every minute, and in iOS 2, that would actually keep our app from entering the background. And so he mentioned that to us, and he said he was able to track his run normally. So it led to us playing a silent audio file while you were running. So we just left that audio file running, and you were able to lock the screen, and the operating system actually wouldn't background us. So a bit of a hack, but... All right, so with iOS 3, 4, and 5, Apple gave us a few new APIs. So they introduced region and heading APIs. So region monitoring is great. We actually don't use it. We don't use most of these at Runkeeper, but region monitoring is cool. You can the operating system will actually launch your app from the background if a user enters or leaves a region. So the next major improvement to location services that we used at Runkeeper didn't happen until iOS 6. So that was the announcement of deferred updates. So deferred updates introduced developers with a good way to actually conserve battery life. So, and you could get deferred updates with high fidelity points. So prior to iOS 6, we had this function here where you would get a new location and it would show you where your old location was, and this would fire every time that you got a point. So with deferred updates, we started getting an array of locations. So to enable deferred updates, you just have to set your accuracy and your distance filter to none. And it'll show up at the bottom here. Very small, sorry about that. I can tell you more about it later. But so you just call on this method on your location manager and you provide the distance and the time interval within, for when you want to receive GPS points, and it will basically turn off the radio for that period of time. And the operating system handles that. But so it will conserve battery life because it just doesn't have to be on for as long. All right, so that brings us to iOS 7. So during the launch of iOS 7, Apple came out with background refresh, which was pretty exciting. It allowed apps to make calls in the background even when their app wasn't on. So you could basically piggyback on other apps' web calls, and you could pull down the latest information. So if you had a social network, as soon as a user opens up your app, all of that information would already be in the app, and you wouldn't have to make the web call yourself. So that was great for developers. Bloggers immediately told users to turn it off because it was killing their battery. So this is my bike ride home last week, and as you can see here, it's tracking pretty well along the road. But what would happen if you turned off deferred updates would be very similar to what we saw in iOS 3. So you'd be going along, and you can see I kind of paused here, and so it drew a straight line from where I started by my office to here, which at some point has me biking through the river, which is not what I did. This caused a huge problem for us. Our users were complaining, and there wasn't much we could do about it. So it led us to this pretty ugly screen where if you turn off background refresh from settings, we notify users and they're like, hey, you can't do that. So we were getting a ton of negative reviews from the previous experience. Launching this dialog also led to negative reviews, but far less negative reviews. So better of both evils. Okay, so iOS 8. iOS 8 didn't add a ton, sorry. Oh, so in iOS 8, they added location service authorization. So you can now have always authorized, or you can have when in use authorization. So always authorized is necessary for region monitoring and for launching apps from the background, where when in use is great for just when you need it in the moment. So we actually use when in use, and the user is surfaced with two different dialogues based on which kind of location services you want, and it's far less intrusive to the user if you just use the when in use. All right, so that brings us to iOS 9 and watchOS 2. So iOS 9, nothing too exciting happened in that. They did add some new permissions, so if you want to run in the background, you have to set allow background location updates. But more exciting was watchOS 2. So watchOS 2 added core location. Now, the location data isn't that great. If you're tracking with just the watch, we're not going to be able to get fine-grained location data because it doesn't actually have a GPS chip in it. But you can get general location. So I believe it hits Wi-Fi or local Wi-Fi points and will get you a general area from that. And watchOS 2 also only works when your app is in the foreground. So even if they did have a GPS chip in it, we wouldn't be able to get the points anyways. So what we're going to use it for, and this is kind of an early insight into our next release, so we're going to use the location services in Apple Watch so that if you track with just the watch, we'll show you the general region that you were in. So that's just my neighborhood kind of behind the text that says tracked with Apple Watch. All right, so setting up location services is pretty easy. So this is it on iOS. So you basically just have to register yourself as a delegate for Location Manager. You have to set a desired accuracy. And so the desired accuracy there is the region of accuracy, or sorry, the radius of accuracy that you want your GPS points to be within. Distance filter, so you basically tell the operating system, hey, update me every 10 meters, every 50 meters, or just update me every single time you get a point. And then it's requesting when in use authorization and starting up location services. So as soon as you start using it, you'll find out that location services is very noisy. So this is the API that I showed earlier. It's in Swift here. And so you get an array of locations back. And so, like I said, you'll find out that location services is very noisy. It's just going to give you tons of points, and you're like, oh, but I only needed 1 point, or I don't need this many. So not all points are good points. A point has to pass a few tests before we're willing to save it. We have a few basic filters that we require a point to pass before saving it. Those filters were created over time and have improved based on the many issues that we've run into. So our filtering algorithm. So location services provides you with points that are within a certain degree of accuracy that you requested. So while location services is starting up, the points are actually more inaccurate than you might specify. So for tuning our algorithm, we need a large set of data, which means many, many trips. So for debug builds, which are used primarily by Runkeeper employees, we store every single point that we get from location services to the local database. That ends up being pretty battery intensive. So we're not only collecting all those points, but we have more log messages that happen in those builds, and then we're actually spending all of that time writing to the database. And I found that out firsthand my first year at Runkeeper. I ran the 2011 Boston Marathon. And so I'd been going on lots of runs, and I ran a 20-mile run, and it burned like 40% of my battery. But on race day, and that was on a production build. But on race day, I had the great idea of installing a debug build because I wanted to test something else out and didn't realize the implications on the battery life. So 13 miles into my run, my phone dies. I was not very happy. I ended up throwing my headphones into the woods. But yeah, so that's just a little difference between what we have for production and what we have for our debug builds. So just as an example, for a 6-kilometer run, if you don't filter out points, we'll get about 2,300 GPS points versus about 600 points that we actually need to store for the release builds. All right, so what do we see when we get a GPS point? So you get a horizontal accuracy, and that kind of tells you within the radius of certainty. And what points do we throw out? So we don't accept any cell tower points, and you can tell if it's a cell tower point by looking at the vertical accuracy on a CL location. And if we get a vertical accuracy of less than 0, we assume it's a cell tower or Wi-Fi point, and it's therefore not accurate enough for us. So we also check the age. Sometimes GPS points come in out of date, so we'll get a point that will be before the previous point that we got, and that just seems weird to us, so we throw those out as well. Next, we look at acceleration. So as you can see here, what we'll look for is if you're running along in Moscow and then all of a sudden your next point is on the other part of the city, it's probably not that accurate, probably not a point that we want to use. So we just have a simple check to see, if you accelerated across the city like Superman. And last, we check if the horizontal accuracy is less than 0. Apple, in their docs, say that any point that has a horizontal accuracy of less than 0 is invalid. Not sure why they give it to us, but they do. All right, so as I mentioned before, GPS data, we use GPS data for both fine-grained trips and for tracking the general area. So the image on the left here is of a run. And on the right is, it is also of a run, but you'll notice in the bottom part here, it says Jake ran near Boston, Massachusetts. And so you can use location services to use, you can use location services for reverse geocoding. And you can do that on both iPhone and Android. And it's pretty simple to do. So if you just take a look at the Android code here, we create a new geocoder. We pass in a longitude and latitude, and we'll get back a list of addresses. And then based on those, the list of addresses, you can actually show where the user is. All right, so next I'm going to take you through a couple features we've implemented at Runkeeper and some specifics on how they leverage location technologies, as well as how inaccuracies of location services has caused issues. So, auto pause. Auto pause is exactly as it sounds. It's a feature that allows users to pause their activity without having to take any action. So, for that, and yeah, because we don't want users to be running along and then they get to an intersection and they have to like mess with their armband, and you know, the thumbprint doesn't actually work if you're trying to use it through the screen, and you just end up losing 15 seconds. And if you're super concerned about your pace, it can wreck your run. So what we have is we'll check to see if they've left a certain region. So right there, you can see that the person has continued down the street, and we're like, okay, they're further along. They must be running still. But then if we get a new point and it's within that radius that we've specified, we're like, all right, they've probably stopped, and we'll automatically pause it for them. All right, so we use the common filter at Runkeeper, and it's a common smoothing algorithm. And so what the common filter does is the common filter is made to analyze a list of GPS points and adjust them to smooth them out. This is important because if you use the raw GPS data points, your run's going to look something like this. Especially if you're running between tall buildings, it's just constantly bouncing back and forth off the buildings. And a user sees this and is like, I didn't run into that person's house. So we use the common filter to smooth things out, but typically, so that your run would look something more like that. But typically with the common filter, you adjust all the points in the run. So as you're going along, if you get a new point and that's the 6th point, it'll go back and adjust points 2 through 5. But we're unable to do that because of features like auto pause, where we can't adjust previous points because you don't want to be pausing and unpausing a user's run as you're kind of filtering over their points. All right, so some GPS weirdness. So I talked about some of the history of GPS and what to do when you receive points and what to do when you receive bad ones. So you might ask, what are some of the issues that we've run into with GPS points over the years? And back in 2012, we ran into one that we like to refer to as the Android shuffle. So the Android shuffle hit us pretty hard. It was happening to about 0.1% of users. So you can see here that a person probably began their run around here and ran in a circle, and then they got up here, and it looks like a kid came through and colored in their loop. And so we kind of zoom into that a little bit, and you can see that it still looks pretty colored in. And then if you zoom in even further, you can see that the points are bouncing back and forth. So it looks like this point on the far right is probably drawing up to a point higher above it. And if you zoom in across this area, you'll see that all over the place. So for us, it is kind of difficult to actually reproduce issues like this. It involves someone going out for a 2 or 3 mile run, and you can do that maybe once a day, but your QA guys get pretty upset if you ask them to do it too many times. So we see an issue like this, and at first it looks like it's just got to be some sort of sorting issue, right? So users were telling us that it was working fine while they were running, and they were getting audio cues of the correct distances, but after the run, it was just totally messed up. So I'm like, all right, let's check out our sort function. And so I looked at our sort function, and it's comparing timestamps, and I was like, all right, that seems pretty straightforward. Couldn't be that. And so it turns out that we were actually setting the timestamp on each GPS point as the system.current time in milliseconds. And right in the Android documentation, it says, don't do that. So what can happen here is if a user is actually running near cell phone towers that for some reason have different timestamps associated with them, it will actually change the system clock. And so using current time in milliseconds uses the system's clock, and we would associate those times with the GPS point. So if you're like running near time zones and you're constantly having your phone's system time updated, it's going to look fine while you're running, but then after your run, when we go and try and sort the points by timestamp, it looks like someone colored them in. All right, so elevation. We actually don't use the elevation on GPS points. We kind of made that decision back in like 2008 when we found it to be totally inaccurate. Don't let me deter you from using it yourself, but we just haven't really tested it recently because we're happy with the service that we use, which is called topo coding. Okay, so we spent a lot of time talking about the technical side of what we do for smoothing out data, but GPS data just tends to bounce around, tends to not be totally accurate. So you can see here on my run, this one actually doesn't look too bad, but you can definitely see how the lines squiggle a little bit. And so what we found over time is just the way that you present this data to the users can have a big impact. And so we were getting lots of negative reviews with people saying that, as I showed in a previous slide, that they were running into people's houses or running through the river. So we actually just made the line here wider, which I know sounds trivial, but just doing that caused us to not get as many negative reviews. So there you go. All right, battery life. So battery life, you don't want to be in the top of this list of battery usage. So right there it has us at 35%, and that happens when we do things wrong. GPS is a big killer of battery life, but some of the other big killers of battery life are things like network calls. So while a user is going out for a run, we don't allow for any network calls to happen from within our app. The one exception to that is we have a live tracking feature so that you can see where your friends are running while they're running. And the other point here is that there's API methods that both Apple and Android provide that you notify the system when your app is entering the background and when you don't need to collect location services anymore. And so it's really important to call on those methods. Additionally, don't call on location services if you don't need it. So for us, most of the time when users are using our app, they are using it to track a run. So as soon as they open up the app and land on our start screen, we kick up location services and we try to get pretty granular points. But that might not be the case for you. So if you want to limit your impact on battery life, I just use it whenever you need it. All right, so in conclusion, iOS and Android are both continuing to improve the ease in which to use location services. So with watchOS 2, you can use HealthKit to actually just get a distance that people are running. So you don't even need location services as much on watchOS 2. And then next, just consider the user's perception when displaying their location data to them. It's crazy that just drawing a thicker line can actually cause your App Store reviews to get better. And last, just always be thinking about battery life. Any questions?
Да-да. Я вижу. Секунду, у меня просто для первого вопроса есть важный ритуал. Подожди, Оль, сейчас.
There's a ritual rite to be performed.
Activity started.
Fun fact, the voice in our app is the girlfriend of our CTO.
Hello. In Android and probably in iOS, user can fake GPS data. Do you handle this case?
No, we don't handle that case.
Нет, мы не используем.
I guess that would kind of be their own fault. So there's not much that we can. I mean, I'm sure we could do something about that, but no, we haven't worried about that.
Thank you.
That means I can fake the results of the nearest Runkeeper competitions.
You could do that. I mean, we haven't seen that to be a big enough problem yet where we have attacked it. But right now, some of the prizes for our competitions are pretty small, so we're not too worried about it. But if we started offering a prize for a few $1 million, maybe we'd have to make sure that users aren't trying to cheat the system.
Hello, a wonderful presentation. First of all, I have a question about, do you use core motion framework to detect is user now walking or running, or he just stopped, or you use only GPS core location?
Yeah, so I don't believe that we're using core location in any way right now. I know we've definitely looked into it in the past, but right now all of our runs or our activities are just a walk, or we just have them labeled as a run. So we don't allow you to switch back and forth between activity types while you're running.
And do you use core motion framework?
Yeah, sorry, no, we don't use core motion.
Oh, okay.
Господа,
Dear ladies and gentlemen,
what do you think about analyzing the data about real buildings and streets got from map to put your way between these buildings, not to cross them?
So if I understand your question correctly, you're saying, couldn't we just look at map data to try and smooth out a user's run?
Yes.
Yeah. So we have looked into that in the past, and yeah, we haven't started doing it, but it is a good idea. It would be a substantial amount of work, I think, and I mean, it depends on how good the maps in the area are. So we have a lot of runners who will run on trails, and trails aren't always in those maps.
Hi. What about QA? Who is these guys? They are robots?
They're in very good shape. Yeah, so we have 3 QA developers, and we have a treadmill in the office, and we go on a lot of test walks. So when I was working on our WatchOS 2 app, I did a lot of exploring of Boston and just constantly walking around. So.
Okay, thank you a lot.
Activity stopped.
Thank you.